Hi guys, today we're going to start lesson 3.2, which is all about solving inequalities using addition and subtraction. This starts on page 409, I believe, in your iBook. And the first problem we're going to look at is the addition property of inequality. And all this addition property states is that if A is, and I'm looking right here, if A is greater than B, then A plus any number will still be greater than B. And the opposite is also true. So if A is less than B, then A plus a number, we'll say C, is still going to be less than B plus that same number, or plus C. And then I noted here that this property is also true when using the greater than or equal to sign, and also the less than or equal to sign. So if you look below, I have two examples. If we say that 5 is greater than 4, this is going to mean that 5 plus 3 is still going to be greater than 4 plus 3. Okay? The second example is -2 is less than 0. So -2 plus 1 is still going to be less than 0 plus 1. If we did the math here, -2 plus 1 will leave us with -1, and 0 plus 1 is just 1. So -1 is less than 1. This is true. Okay, if we used a diagram to check this, here we see that B is less than A on the number line. If I add B plus C, I'm just making these figures up, right? We'll say that's B plus C. And then we think about it. A plus C will be over here on the number line, right? So B plus C is going to be less than A plus C, which is just a diagram example of the property we talked about above. Okay, so problem 1 wants us to find the solutions and graph them for the given inequality. Now remember, we can treat inequalities like equations. What I mean when I say that we can treat inequalities like equations is that I want X to be isolated. I want X to be all alone on one side of the inequality symbol. So I need to get rid of this minus 15. How do I undo the operation of subtracting 15? What's the opposite of subtraction? It's addition. So I'm going to add 15 to each side of the inequality symbol, okay? These will cancel out, and I'll be left with X is greater than 27, okay? X is greater than 27. Now I need to graph it. If I graph it, I'm going to start with my number line, okay? And I'll put 25, 26, 27, 28, and 24, 23. Okay. If X is greater than 27, I'm going to have an open circle above 27, and because it's greater than, I'm going to go to the right on the number line. So that's how we would use addition to find the solutions of the inequality and graph it as well. Okay, here's a second example of how we're going to use addition to solve this inequality. The problem does ask us to, the problem does ask us to graph. If only I can get this screen to work. Graph and check. All right, so I'm going to rewrite the inequality, and it's 10 is greater than or equal to X minus 3. Remember, I need to isolate X. So how do I get rid of this subtraction of 3? I need to undo it. I need to do the opposite. So I'm going to add 3 to each side. Okay, my 3's will cancel out, and I'll be left with 13 is greater than or equal to X, or we can rewrite it as X is less than or equal to 13. And now I have to graph. So If x is less than or equal to 13, I'm going to have a shaded in circle above 13. And because it's less than or equal to, I'm going to go to the left on the number line. Now we're going to shift and talk about the subtraction property of inequality. So again, let A, B, and C represent real numbers. If A is greater than B, then A subtracting number, we'll say C, will still be greater than B subtracting that same number, or C. And the opposite works for this one as well. So if A is less than B, then A minus C is also less than B minus C. Okay, same thing goes. This property is true for the greater than or equal to and less than or equal to symbols. So below we have two examples. If we look at the first one, we have -3 is less than 5, which means -3 minus 2 is also less than 5, or less than 5 minus 2. So let's check our math and make sure. I know that -3 minus 2 will leave me with -5, if my pen wants to write. And 5 minus 2 will leave us with 3. And I know that -5 is less than 3. So it's true, it works. The second one here, we have 3 is greater than -4. So 3 minus 1 will still be greater than -4 minus 1. Again, let's do the math and check. 3 minus 1 will leave us with 2. And -4 minus 1 will leave us with -5. I know that 2 is greater than -5, and that one is true as well. Okay. Now, if we look at the diagram here, I know that looking at this number line, A is less than B, right? Let's say I subtract C. It can be, I'm just making this up. Okay, let's say this right here on the number line would represent B minus C. A minus C is going to be over here somewhere. Okay, this is A minus C. If I'm looking at the number line and B minus C is right here, then B minus C is greater than A minus C, or A minus C is less than B minus C, which corresponds to A is less than B up here. Okay? Just when we were using addition to solve inequalities, we can also use subtraction. Remember how I said I can treat my inequalities like equations? The same goes for subtraction. So if I have that t plus 6 is greater than -4, I need to isolate my variable. I need to get t alone. 6 is being added to t. So how do I undo that? Well, I'm going to subtract 6 from both sides. My 6's will cancel out, and I'll be left with t is greater than -10. If I want to graph that, I have to draw my number line. Okay, since t is greater than -10, I'm going to have an open circle above -10, and I'm going to go to the right on the number line. All right, guys, one more problem, and then we are done. This is a word problem that says your iPhone can hold 120 gigabytes. You have used 85. You want to be able to keep taking videos on your phone. What are the possible sizes of the videos you can save? I always start by underlining what they give us, so I know that my phone can hold 120 gigabytes. I know that I've used 85 gigabytes, and I want to find out the possible sizes of the videos I can save. So I know that what I already have, 85, plus what I'm going to save in the future, can only be up to 120 gigabytes, okay? So I'm going to start with what I have, which is 85, plus what I want to be able to save in the future, and I don't know that, so I'm going to use a variable, x, so the possible sizes of our future videos will be represented by x, and I know that this number has to be less than or equal to 120 because that's all my phone can hold. Again, I'm going to treat this like an equation and know that I need to isolate my variable. I need to get rid of this 85. If 85 is being added to x, how do I undo it? Well, I want to subtract 85 from both sides. If I do the subtraction, I will be left with x is less than or equal to 120 minus 85, I believe is 35. Okay, so x is less than or equal to 35. So the possible sizes of the videos I can save can be up to 35 gigabytes. Okay, so here we just have a couple or a few examples of what we learned today. I'll do the first one, and then tomorrow I want you to come to class with the last two you guys having tried on your own. So the first one says that p subtract 4 is less than 1. Remember, I want to get my variables alone. I want them to be isolated. So I need to get rid of this subtract 4. In order to get rid of it, I have to undo it. I have to do the opposite operation. So I'm going to add 4 to both sides. What will happen then is my 4's will cancel out, and I will be left with p is less than 5. And that is my final answer. So I want you guys to try the two below. You do not have to graph these, okay? You just have to solve them. Remember, come to class with any questions you may have. I want to see your notes tomorrow, as well as the last two problems. I want you guys to at least try them. Thanks. Have a good night.